Okay, great. Let's start this. Hopefully everyone can hear me all okay. See, we've got some people in the room, so we should have started. Sorry, just bear with me a second. I'll just check that everything's all okay here. Okay, great. All right. All right, so thank you for joining us. Good afternoon and welcome to our streaming technologies overview. My name is Mark Hall. I'm from Corsair Solutions. And look, today I suppose we're diving into some of the world of video streaming protocols. I'm going to give a practical live demonstration. A quick housekeeping, the session has been recorded. Please feel free to ask any questions in the chat. We'll have some Q&A time at the end, but I can also talk about any sort of questions as we go. So this is just designed really as a high-level type overview and to give you a run through. So I'm not covering everything, but I'm just trying to keep this as really simple and just to go over a few things in I suppose a prequel to integrate and just talk about some of the different technologies that we have and that are being used. Can everyone hear me okay? I think so. It looks like my audio is working fine. Just double check. There's nothing worse than going out without any audio. All right, great. Well, let's kick on. Let's go through this. So look, our agenda is going to cover some streaming fundamentals. I want to differentiate, I suppose, some of the differences between, I suppose, internal and external streaming. After that, going to dive into some of the more core used protocols like NDI, RTSP, RTMP, HLS, and even SRT. I'm not going to cover any of the closed protocols, things like the J2Ks and things for proprietary systems like Crestron or the Visionary. I'm more talking about some of the open source ones here. I'm also going to talk about getting through corporate firewalls without requiring additional IT resources. And this is not in a bad way, but this is something that's come up in our road shows and using SRT, and it might be good just to know about this sort of protocol and how it can be used. So I'll be doing a live demonstration and basic workflows, and yeah, I'll obviously just opening the floor to any questions after that. All right. All right, so we have a couple of items on here that I'm using. I have an Ultra Encode all-in-one unit, which has actually got a variety of different feeds and SDI and HDMI feeds into it. I also have an SDI Plus. These units are, I can actually show you the units just so you know what we're talking about. If I go and share my screen on here. So the Ultra Encode SDI Plus is this version up here. So it basically is can do up to 6 different streams. We also have a HDMI version, but it also features network recording and scheduling and things like that. The Ultra Encode all-in-one is a single channel encoder, but it actually features multiple inputs. This can actually stream out 6 different streams in different protocols at the same time to different locations. And it can also do like a timestamp or a side-by-side, and that can also be recorded and a full API control as well. So very, very powerful type units. There was some actually used for the Commonwealth Head of Government meeting in Samoa last year for broadcasting the forum right around the world going out. So powerful units. And lastly, we're going to have the IP to USB. So that is this product up here. And reason why I'm showing this product is new from Magewell, but it's very powerful in what it can do because it can actually bring in external and local streams, and it can bring them into Teams, and it can bring them into Zoom. So NDI full bandwidth, HX3, SRT external, internal streams, and with full API, and it's a rock solid type unit. So I'll actually be showing that workflow live. I'll be doing SRT streams here to show how that performs. We've also got also be running through I've got the Director Mini, which I've actually got to show that. So I've got that actually going out into Teams at the moment, which allows me to do, fancy things as you can see here, that I've been doing. So that's all coming from the Director Mini, and I'm actually going out UVC into Teams just to allow a bit more control and to be able to switch through things quite easily. All right, next slide. So let's talk about some of the streaming basics and what is streaming. So really, as everyone knows, and I said, I'm keeping this quite simple. So it's just really an overview. So it's a continuous transmission of audio and video data over a network, playing almost instantly without the need to download the file first. So, you know, any combination of streaming, whether it's local or external, you've got a source, so the camera, HDMI into an encoder, for example, or the camera has an encoder built into it, and then it compresses that video and audio into a streamable format. Then it's pushed out or pulled, whichever way is needed, to your internet connection or your local connection. If it's going out, it can go out on the internet to streaming servers like YouTube, and then that can be pulled into decoders and then play out, you know, and the goal is obviously to deliver, you know, smooth real-time playback with minimal buffering. But it's real, as I've always said, it's really horses for courses depending on what you need and what the application is. So many different protocols for different use cases and different bandwidths and that sort of thing as well. All right, so before we dive into the specifics of the protocols, so I'll explain the difference between the two main environments for streaming, the internal and the external streaming. Obviously, internal streaming happens within your closed network as you've got there, like your office LAN, your campus network, or even a local home network. Generally have a high bandwidth and very low latency, and security is really managed, you know, within that network perimeter on there. As I said earlier, it's worth noting that within these closed networks, there are some products that utilize proprietary codecs or that are encrypted like J2K, and they're designed to exclusively work within their own ecosystem. I'm not talking about those devices today. I'm talking about, you know, protocols that you will get out of standard cameras, whether it's a Marshall's broadcast camera or Lumens, or, you know, even protocols used by Dahua or Hikvision for, you know, security streaming. So while they can offer specific advantages, those systems, you know, we're focusing on the widely adopted open protocols really in their general usage, if that makes sense. So the external streaming involves, you know, similar type setup. So transmitting over the public internet. Here the bandwidth is more variable and latency is typically higher due to the distance in the internet infrastructure, depending on your connection. Security, reliability, and firewall transversal can become major considerations here. You know, examples may include YouTube Live, a public webinar like this one through Teams, or video remote connections. Now, even this with Teams, you know, you don't have control really of what goes out. You just give your output to Teams, and it manages with its AI what it thinks is best. So I see that often when you're actually screen sharing, which is why I'll go through the Director Mini, because it might put bandwidth into the wrong areas. So yeah, that's just some of the things when you're going through external CDNs or, you know, servers you deliver to. So let's talk about some of the local network streaming, and primarily here with encoders and some of the various protocols and how they work. So, you know, everyone's probably heard of RTSP. RTSP is most commonly found in internal network environments, specifically with, you know, IP security cameras and surveillance systems, or, you know, even one of the Lumens cameras down there, or everything pretty much has RTSP on there. They have that as really a standard. Generally latency is around about 2 seconds or so, depending on configurations. It's not a secure format. There are RTSPS and various other protocols that work with it, but it's not generally a secure format for streaming and how it works. We then have NDI high bandwidth. So this designed really to allow professional video equipment to send and receive broadcast quality video over standard IP networks, internal networks. So it's essentially turned your local network into a versatile routing system. Been a lot of changes with NDI. NDI has become more mainstream. There's a lot of software products, but the advantages of full bandwidth NDI are really high quality and very low latency. So it uses a speed HQ codec. It's uncompressed or lightly compressed video, very low latency, offering visually lossless video with sub-frame delay. And that's crucial for some of the live production environments where they're IMAG or have something going to a large say LED screen, for example. It does require significant bandwidth in the full bandwidth NDI, but this is all, relative to what you're talking and what sort of how the network's set up and what you have. So it's generally very good for sort of robust internal local area networks, or if you can manage, actually know what's actually happening in there. And there's also many different ways to push this out: multicast or unicast or multi-unicast, and reliable unicast pushing. So there's many different ways that can be pushed out. We then have what we call HX3. So HX3 basically there was a HX1, which is a H.264 encoding, and there's a HX2, and there's HX3, which has come about in the last few years. And that's really giving users the ultimate video quality expected that use a full bandwidth NDI. And I suppose the vast majority of users in live events, live video conference, production, AV, remote production, will be quite happy with HX3. So it's got a visually lossless video with very low latency in pitch quality and delay. And it's really, in some instances, almost indistinguishable from NDI high bandwidth. But it really depends on the use case. You will actually see a lot of manufacturers going to NDI HX3 now. And you've generally got really below 100 millisecond, or around that, they say officially 100 millisecond glass-to-glass latency. So if you had an encoder and a decoder and, input and output on there, if that makes sense on there. We also then have HLS. Now, HLS streaming, I've been asked for this a bit lately, and basically HLS is an adaptive protocol using HTTP, so it's HTTP live streaming. It's a very different beast, and it really, I suppose it's a dominant protocol for delivering streams to external viewers from a server on the internet across web browsers and mobile devices. So you'll see this often on streams, and whether you're watching Netflix or whatever it might be. And how HLS works is it has a header file that's called an M3U8, and imagine there's different quality streams. So if you had 1 meg of bandwidth, for example, you could have multiple streams in that HLS stream, like maybe a 200K, a 500K, a 700K, or whatever it might be. And that M3U8 basically is as a header file, and the devices actually use that, and it's like an adaptive bit rate. So you'll often see that when you turn things on with Netflix with a bad connection, that it will start off looking pretty crappy, but then it will actually, as things stabilize out or there's more bandwidth available, it will jump to another tier and another sort of a quality. So it's basically leverages standard web servers and content delivery networks, CDNs, it's a very wide compatible protocol, and it works natively across almost all modern devices. With that as well, we are seeing, I'm getting more and more questions about just running into IPTVs and gateway systems. So we can do that quite easy with our Magewell devices. We can create HLS streams that you can push in there. So if you've got a free-to-air set-top box and you need to code it to a HLS, we can help you with that. So it's just something to be aware of. But that's it's something that I wanted to talk about as well. All right, so let's talk about external network streaming, and some of this comes into internal network streaming as well. So I'll just explain some of this. So RTMP, so you've got an RTMP protocol. Now RTMP really was initially developed to deliver live audio and video data over the internet. So typically you have your encoder, and it encodes your video file, and it connects to what's called an RTMP server. RTMP supports adaptive bitrate streaming, and it's used for many live streaming scenarios, from gaming to professional broadcast. So that will negotiate with a server. So when you stream out, and I think I've got a slide here on it, you set up your encoder, and if you're going to YouTube, for example, your device might have a YouTube setting where you just say, hey, here's my YouTube and my stream key. But when you dig deeper, it's actually got an RTMP address in there. So I could go onto some of these Magewell devices, and I could use the YouTube settings in there, which makes life easier. But if I know what I'm doing, I can put a specific RTMP in there, an RTMP address, which is actually what's the server address behind that with the stream key. And that might be useful knowing that for when you've got like backup streams or a backup server on there as well. So once again, I hope this is all making sense on there as well. The next thing I'm going to talk about is SRT. So SRT is called Secure Reliable Transport, and it was actually designed by High Vision many years ago. And you'll hear this often talked about in the staging environments. And people like Vixa wrote a big thing up on it last year about the advantages of it, and it is really a great codec. It's an alternative to RTMP. And it's audio and video codec agnostic. So you could have a 1080p or a 720p stream or an 8K stream, it doesn't matter. And it's designed importantly for streaming both internally and externally. So we can do internal streams, which I'm going to show you running. And there's also security on there as well. And it also forms a bi-directional connection as well. But it's also firewall friendly. So that's one of the things that I'm going to show, and we're going to show you how this can be used, because there's nothing worse than if you're at a live event or you are in a lockdown environment that you've got to wait for IT to find holes in the file for you to go out. But this makes it quite easy to use the SRT protocol. So what we're going to have, or the way it works, is you can have and this is a similar setup which I'm going to show here. You can have what's called an SRT caller and an SRT listener. So let's say that you're a university, or I'm based at a university and I've got a device here. I can be set up as an SRT caller, and I could be in a lockdown environment. Now, SRT ensures that the firewall traversal is done very easy by using a caller listener handshake concept. So it replaces the existing security policies by really allowing outbound connections without requiring permanent exterior ports to be opened in a firewall, if all that makes sense. So what actually happens is the caller goes out. So I could be here, as I mentioned, I might be behind a university or a courtroom, and then I could go out to a listener, and the listener then basically establishes a bi-directional data flow without the need for an IT administrator to open a port. So there's many different use cases that it can be quite handy in. All right, next we've got the decoding. So we've got a variety of different decoding devices from the Magewell. We've got basically, we can decode local external streams, NDI, full bandwidth, HX3, RTMP, RTSP, HLS, HTTP. So many different ways of decoding, and we can spit out HDMI, SDI on these. We have full API control. They have full up-down scaling. We can use these. You could hang one off a projector, and it could just pull an RTSP stream from your security camera, or an SRT stream, or a HLS stream, or then pull a stream from the internet quite easy. Or it can even act as an RTMP server, so it goes straight into that. So if you've got something that goes straight to the internet, YouTube, you can push it straight to this using that setup on there, if that makes sense. So really handy to know about, and very flexible type units. All right, the other thing I'm going to show you is the Pro Convert IP to USB. So this is a new little device we have down here. I don't know how well you can see it. So I've actually got it set up here. I've got it plugged into my Director Mini with a USB UVC and into a network. And basically, it's a plug-and-play device designed for conference room and production studio. So plug it into MTR, bring in an NDI feed or other IP streams into Zoom or Teams without an issue. So it will decode full bandwidth NDI and many other streams, and it will push that out as well to your USB UVC. Coming soon, we just found out about yesterday, it will actually come in as a camera or a content in the new firmware that's coming. So we have a Magewell, what's called a 32060, which is a HDMI capture device with USB, which is Zoom certified. And a lot of universities will use this because they can easily select camera and content. This is going to do the same sort of setup on there as well. So it's quite a handy little device. We have units coming, and we're going to be showing this at the Integrate show as well. Okay, hopefully I'm not going too fast and this is making sense. I know there's a lot in here, trying to keep it sort of sort of simple. So we're going to give you a demonstration. I'm going to show you some of this in action running. I'd like to actually show you a Magewell sort of an IP to USB workflow showing the devices. So as I said, I've got this unit here. Now, you know, we've got many different streams that, you know, that you can use. So this is actually a shot of one of the encoders. You can see different streams, SRT caller and listeners and NDI. But I'd like to show you how this works real time. I'm going to create an SRT caller and a listener through some of the devices and show you how this performs. So if you bear with me, we'll show you this, and I'll give you a bit of a run through. So let's just go back to here. Let's flick over to here. And so first of all, we have a well, I've got a camera over here. I've got a don't know how easy you can see it. I've got a couple of cameras running into the encoders. And what I'll do is first of all I'll show you we have an ultra encode. So the ultra encode is, as I talked about earlier, is this little beastie here, and I've got a variety of different feeds running into it. So I've got both SDI and HDMI, and I can put my little get my finger on it there. This is just a preview, so it's low latency on the web GUI. But that's basically that ultra encode, encoder there. So I've got that set up. I've also got a ultra encode SDI plus here as well. So that's over here, and that's actually got a that's showing you the basically the SDI that's coming into it. I've got two cameras running on a little turntable there, showing some different metals. And then we've got our IP to USB device. So our IP to USB device is this new Fandangle product that I was talking about. And if we go over to the GUI here, we'll actually see here is basically the web GUI of the unit. And we've got Ethernet connection, USB, and we've got options. So it's actually got a no signal image. So you can see if I flick to, I can actually flick to that output there. So that's what's coming out of the USB, IP to USB, and that's the coding. So I've got no signal on there at the moment. And as I said, what I want to do is I want to show you this this firewall type this setup here. So I want to show you this setup. Showing you the device, but we'll show with an SRT caller and a listener and how that works. All right, so let's just go back over to here. So I'm trying to explain this as simply as possible. So what we'll do, we have our ultra encode. So ultra encode is here. So imagine this is set up externally to where I am at the moment. I'm in the Corsair Melbourne offices. Maybe I'm over in South Australia, and I know where this IP address is. Right? I can set this up to be what's called an SRT listener. Now, what this will do is this will just listen here on that port. So all I need to do is I need to set up what's called an SRT listener, and you just can basically go on here and you can add it. Here's one I prepared earlier, and you specify the port. Right? So this is external. I am, say, locked down behind a firewall. So this is external, and someone external has got the encoder happening, and this ultra encode all in one is somewhere else, and it's just sitting there, and it's streaming, but it's actually idling. It's waiting for a connection. Then we come back to the IP to USB, which is this device here. And then we can actually set this up. And if you see down here, down the bottom one here, I can point this to this IP address of this device that's waiting at the moment, right? So I will show you that. And let's go back to here. It's set up to that IP address and that port. So it's going to send out, and this can navigate the firewall. And if I click on him, let's see what happens. So I've told him to go on, and something's happened. He's connected. And straight away, I can see that this device that might be here could be connected over the network, going through the firewall. And now I see that this is actually connected there. So this is actually negotiated a stream from the basically the device I have down the bottom, the IP to USB to the encoder on there. Now, what that's going to look like is I will show you that stream, and I've got that stream coming in right here. Sorry, that's actually the stream that's generated from the device. So you can see that there, and that's basically an SRT stream. I'll put my hand in front of it, and that's an SRT stream that's coming in from that encoder. So to show you that in action, you can see that probably in the picture there. I'll turn off the SRT connection. I'll stop the live, and it actually will lose the connectivity from that device and from that USB connection there. So I've got no signal. So that is, I suppose, really a demonstration of how that can be used. I also have, as I said, the SDI plus, and I can do this one is IP is 192.168.1.7. I can have him set up to actually pull to the other device as well. So here is my caller mode set up as 192.168.1.7, and he will be calling out to the SDI plus, which is this one here. So we'll make sure he's on remotely wherever he is out on the internet. And we can turn this one on here, and this will, if all things going well, this will negotiate and say, oh, there we go. He's actually connected, and he's bringing my stream in. Yes, so he's streaming from my encoder, and he's been pulled into my IP to USB device, which is showing here. So go to here, and that's a stream coming in. So that's basically an SRT stream that I've set up that's actually coming in from an encoder here being generated, and it's been decoded by the IP to USB. So apologies if that's a bit of a mouthful, but I just wanted to explain the principle and how it actually works, showing the USB IP to USB decoder. And as I said, this can be done by any of our products to create the streams. If I was, as I said earlier, to go on to here and I went into any of my encoders, I can simply go in and I can create new destinations and set that up as needed. And I can also do other streams we talked about, you know, the RTMPs and RTSP. There, as I mentioned earlier, YouTube. So YouTube's actually got HLS as well as RTMP, different protocols on there. So I hope that makes sense, and you know, apologize, it's a bit of a mouthful, but I just wanted to show really some of the SRT caller and listener workflows and how they can be used. Please feel free to obviously reach out to me after this. This is just supposed to be very high level. I'm also going to be at Integrate, obviously, with all our staffs and our BDMs, so please yell out there as well to go through things. So once again, I'm really sorry if this is confusing, cause any issues, but it's more just it was supposed to be a high level overview to give you a bit of a run through. So I am going to be putting this up on YouTube as well, but you know, I am available. Drop me an email, or you know, send an email to sales@corsair.solutions or corsairsolutions.com.au, or give us a call. So thank you for your time. Hopefully that was all okay, and I look forward to seeing you all at Integrate. All right, thank you.